Everybody's clear on that? Okay. Now for labeling pertinent features of the cold, worked, and annealed microstructures. So you've got your micrographs. Everybody should have their micrographs at this point, correct? Okay, good. So I want you guys in the additional observations to identify magnification level. Again, just based on what I've seen from other lab groups, everybody had a hard time understanding. I need you guys to write 500 for each additional observations, okay? So you should write 500 twice. Does that make sense?
Yep.
500 under each additional observation section, level. So that I know that you guys used 500 times magnification for each micrograph.
Don't we have to like measure like the length of the screen? Or?
No, there's no grain size calculation for this lab. Oh, I just want, yeah, you're just looking at you're observing, that's all. All right, so you're going to write 500 times under each additional observation box. Everybody's going to get 100% on that, really straightforward. Then you guys are going to take a pen or pencil or marker or whatever, and you guys are going to identify and outline a grain on the micrograph. You're going to do this for both the compressed grain structure as well as the annealed equiaxed grain structure. Is that clear?
Yep.
So take some sort of a pen and just outline a grain. This is done such that I understand that you guys understand what a compressed grain versus an equiaxed grain looks like. I then want you guys to draw arrows indicating the direction of force applied for the compression of the grains. So the grain was initially like this, and then it was squished like this. I want you guys to show arrows saying that it was pushed in this direction, such that I know that you guys understand what direction it was compressed in. Does that make sense?
Yep. Is that for both, or only the one that was not annealed?
Only one of them is going to actually look squished, so for only one that was squished. So again, both of these samples have been 70% cold worked, and then one was annealed. So you're only going to be able to see the compression on the non-annealed sample, because when you anneal a sample, you have recrystallization and regrowth of your grain structure, which takes a look at the which makes them look like equiaxed grains again. Is that clear?
So we draw the arrows of compression of where
the force applied, the direction of load applied, so that I can see what direction you guys figured it would be compressed.
So on the we're gonna have a
You're gonna have an annealed and okay, so here. Let me see these pictures. Okay, so this is your annealed, this is your compressed. You guys can kind of see the difference? This one's clearly compressed and this one's been compressed and then annealed, so you just see equiaxed grains. You see how the grain structure is kind of squished like this, so it's striated? So the direction of the force on this would be exactly. Perfect. No. So that's clear?
It's in this direction, right?
And then I need you guys to outline a grain and outline a grain. Alright? Everybody's clear on that? Everybody's going to get 100% on their micrographs? Yeah? Equiaxed, yeah. So all equiaxed means is approximately the same size on all sides.
Your direction, you just did this, right?
Yeah, so I want you guys to just draw arrows.
Okay, what do we write under the direction of force applied? Because there's...
I want you to indicate it actually on the graph.
Okay, what do you actually write under the title?
If you've already indicated it, you can either draw a grain size and indicate it, or you could actually indicate it on the micrograph itself. I don't care how you do it, just indicate it. So I need arrow directions. So take a pen and draw the direction of an arrow where it was compressed.
I guess I have to label it or something.
Yes.
Once you outline your grain structure.
Anyways, moving on to hot and cold rolled observations and determination. So, you guys need to indicate the characteristics which you are using to determine which sample is which. So, you guys need to use factors such as bend resistance, appearance, surface scale, and thickness. They're all labeled and discussed in the actual question itself. They tell you to use those identifiers, so please talk about all of those things. Now, you guys have two samples of sheet metal. One is cold rolled and the other is hot rolled. You shall refer to them as the dark strip and the light strip when identifying them.
Oh, can you go over the what's after band resistance?
It's in the question. Like it's actually written on the question.
Is this for 2.3 itself or just additional observations?
No, this is for 2.3, I believe.
Surface appearance and definition.
Yep.
Oh, I see.
Yep. That's all you need to do. Just discuss all of them. I'm literally just repeating what's already in the
Okay.
thing. So indicate that, and then use try and identify which is which. You will refer to one as the light strip and the other as the dark strip. Does everybody understand which one is the light strip and the dark strip? I know that one of them, that they're both very rusted, so it is hard to kind of identify, but I need you guys to confirm that you guys know which one's the light strip and which one's the dark strip. Can I get a yes from one person in each group?
Yeah.
Yeah.
Yeah. Yep. Okay, perfect. Now, I would like you guys to specifically pay attention to the presence of surface scale, which covers the surface and will potentially change the color of the sample as a very major identifying factor.
How do I know if this got surface scale?
So coloration of the surface.
Can you just repeat that?
You pay attention to surface scale specifically. It is probably your best identifier. Talk about everything else, but when you're determining what is what, I would use surface scale over other things. So, okay, so we're going to discuss hot and cold rolled steels. I'm not going to talk slowly. I'm just going to talk to you guys. You guys should generally understand what I'm saying. Don't try and copy down what I'm saying because then everybody will get confused, okay? So, cold rolled steels, basically what happens is you have compression rollers. You put the sample in and it rolls it through. There should be a really pretty diagram in the lab manual that explains exactly what's happening to that grain structure. So you're compressing your sample, okay? This causes cold working, which allows for higher strength of the surface. On top of that, what it's also going to do is it's going to change the dimensions of the surface, okay? Now, when you hot roll something, those rollers are hot. And so when you roll the sample through the rollers, it's hot and so the sample deforms easier. In addition, there's not as much internal stress which is present because you're basically putting the sample through the equivalent of recovery while you're already compressing it. So the stresses which are normally induced when you compress something aren't present, although you still are deforming your grain structure, so you will still have certain properties which will be present for it. So among these things, what happens is hot roll does not have very good dimensions, and it usually has like uncontrollably changing dimensions, where cold roll usually has very fixed set dimensions, okay? Now the problem is that these samples are so old that they may not necessarily have that anymore. And on top of that, you will also have something called surface scale, which will be present on something which is exposed to heat. So that surface scale will be produced through oxidation at higher temperatures. Is that clear?
What does surface scale look like?
It's discoloration from normal steel color.
When
I
you
kind of have to
when you hot roll something, does it still go through recrystallization in the 3 stages?
It does not go through recrystallization, no. So you still have compressed grains, it's just that you have mild recovery, which allows for a reduction in internal stresses. It'd be like putting it through the 300 stage, if that makes sense. So there's no recrystallization of grains, there's no rebuilding of grains, but there's a relaxation of the compression. So when you compress something, it causes internal stresses to be introduced, and to break the sample or to deform the sample, you have to overcome those basically stresses before you can do anything. Does that make sense? Okay. So now we're pretty good with that, I think, right? Also, the reason why you would hot roll something over cold roll something is because it actually requires less energy. To compress a sample completely cold takes a lot of energy and a lot more force. If you heat it up, it takes a lot less force, which means in an industry setting, it's cheaper for them to hot roll something instead of cold rolling something. Unfortunately, when you when you hot roll something, you lose your tolerances and you change the surface finish.
When you said you hot roll something, it doesn't go through recrystallization and building up back of grains, so it has like long grains.
Yeah, it still has your compressed grains. It's just that there's a relaxation of the internal stress.
Okay.
Does that make sense?
Yeah, thicker then? Not fully.
It doesn't go back to like normal grain size.
No, but it may become a little bit thick because you still have that relaxation of stresses.
Does internal stresses like relate to strength or anything like that?
Yes, so it will change the strength moderately, but it's not a huge change. So as they said, right, when you have higher internal stress, that means that to be able to break the sample, you have to overcome that stress before you introduce fracture stress. Make sense? So you're releasing that level of stress. Is that clear? Everybody's pretty straightforward on that? All right. Okay, so moving along, you have to have your sample calculations for percent cold work and tensile strength. We already went through that. I need you then to identify what the unknown sample is. And I need you guys to use the conversion chart in the lab manual, which is table 1, I believe. Somebody just fact check that for me. It's table 1.
Table 1.
Table 1, yeah?
Yeah.
Okay. Table 1 gives you the approximate strength of different materials based on your tensile strength and based on your annealing after a cold work sample and then an annealed sample. Does that make sense? So you're able to figure out, based on that pattern, what your sample should be. So reference that chart. Again, you need to reference it, okay?
Based on tensile strength.
Tensile strength based on cold working and annealing properties.
Okay, so for cold work and annealing, you define that as after 30 ton, 40 tons or maximum?
Yeah, so let's see here. Somebody give me a table.
Is it in the manual?
Yeah, it's here. No, it's not there. On table 1, it's table 1 of the lab manual. Okay, so there's your as rolled and then there's your annealed properties. So if I was to take a look at my annealed properties and I was to take a look at my tensile strength of say 1020 through 1095 and I looked at the annealed values, I could go through the megapascals and find out whichever one I think is closest to my annealed tensile strength for those materials. Make sense? So once I've done that, then I can take those values and I can compare them, and using that fact, I can identify what I think the sample is. Okay?
Can we use the value after 300?
15 minutes is up.
Okay, perfect. Sorry, what was that?
Can we use numbers for after annealing at 300 degrees Celsius or 500 degrees Celsius or 800?
Do you use numbers? No, after 500 degrees and 800 degrees, because it's not technically fully annealed. You've only partially annealed it until you go to the full temperature. Make sense?
Wait, so table 1, it says it gives approximate strength based on the annealed properties?
Yes, so based on annealed versus as rolled versus tempered, okay? So you want the annealed values. Usually that's what I'd like to use, but you can basically, at this point, you guys should kind of figure out and be able to understand how to use a table to try and identify something. It's pretty straightforward, okay? So everybody's good on that? Everybody understands how I need you guys to identify the sample? Okay? So, then from there, you're going to identify it, reference the table. Again, as I said, make sure you reference the table, because if you don't reference the table, then there's no way for me to figure out if I know, like, where you guys are getting that information from, okay?
Sorry, just a quick question. You said after the final anneal?
Yes, that's usually the best way, because you don't know what as rolled properties they're using for that table, right?